Well, that was fun. So my name is Bailey Hayes. I am a software engineer working at SingleStore. SingleStore makes a database. And you're probably wondering why I want to talk about WebAssembly at a DevOps conference and talking about WebAssembly in a database at a DevOps conference. Well, hopefully by the end of this, I will have explained and perhaps convinced you that WebAssembly is something that you should consider adding to your infrastructure stack. So I first started working with WebAssembly when it was first announced around 2015. I was using it in a very, I would say, conventional use case, what you would expect given the name of WebAssembly. I was running it in the web. We were creating a data visualization library that allowed us to take basically 2 million lines of C++ code, transpile it, and make it run in the browser. And that was really cool. It was really fast. It really enabled us to have basically portability for that code. So then we were running it on iOS, Android, Windows, Linux, everything. And that is one of the initial promises of WebAssembly. Now, there's a running joke, so it's especially funny because we've all said WebAssembly over and over again, that WebAssembly is basically a terrible name. It's neither web nor assembly. It's an assembly-like language that lets you target a virtual stack machine. Kind of complicated. The idea is that if you have a runtime that accepts WebAssembly, then you are able to run on just about any type of device or architecture that that runtime runs on. And you don't have to change your WebAssembly module. And something kind of amazing about WebAssembly is that the browser vendors got together and did something that they've never done before. Well, they do it sometimes, rarely. And that is agreeing on something and creating the fourth language of the web. So by the end of 2019, WebAssembly MVP was available in most of your browsers, and it was a recommended web standard. But if you think about why would the browsers add another language, it's been a while. So what would cause them to think and all agree that this is a good thing to do? And there's a few properties of WebAssembly that make it really interesting and compelling for the web, the browsers being a very constrained environment, that recipe makes it incredible for so many other use cases. And so I remember following all the docs, the design documentation for WebAssembly, and refreshing every day, and paying attention to the language of what they were going to do and what they were going to create. Because it was in 2011 that I was actually working with a technology called Wasm.js. Wasm.js is this smaller subset of JavaScript. It really was, I would say, probably the most glorious hack I've ever seen in a technology. But this engineer from Mozilla, Alon Zakai, he had this amazing intuition that a lot of the reason why JavaScript engines are slow is that JavaScript is an interpreted language. You can change types and do all kinds of dirty things. And the browser has to kind of watch out for you being a bad programmer. And if you eliminate a lot of that, you can get incredible performance. And that incredible performance meant we can do something that we've never been able to do in browsers before. So with WebAssembly, even in 2015, they knew that it wasn't going to be just for the web. Even though they named it in a bad way, I'll give them a hard time for that. But we knew that it had to be sandboxable. And I don't know about you, but when I go to a web page and it takes more than a second to load, I jump away. I just assume the page is broken. Statistically, most people do that, which means it's got to download really fast. It's got to start really fast. It also needs to be compressible. And fun fact with WebAssembly, it actually streams over the wire. It can have streaming compilation as it's being downloaded so that when you have all the bytes, you're ready to run. Now, that is incredible in a number of use cases if you think about it. Like, wow, I want to run my programs really fast everywhere, maybe in Kubernetes. And finally, the reason why they would add a fourth language for the web is that they need to enable new types of tasks for the web to run, computationally intensive. Think about, maybe video games or maybe AI and ML. So WebAssembly, you can see in a landscape of so many other things. I would say in probably the past year and a half, I've just seen sort of an explosion where everywhere I look, I see Wasm. And that's what I'm going to call it from now on, because I really hate the name WebAssembly. So I'm not going to make you all chant Wasm back and forth, but stick with me. That's what I'm talking about. Since this is a DevOps conference, you might recognize a few of these. Envoy, which is a sidecar proxy that runs in Kubernetes. It allows Wasm modules to be like a plugin. So if I wanted to filter my HTTP requests, I could do that. And provide something that's not C++, which is what Envoy is written in. I could write something in Rust and do something safe, secure, and modern. Now, another one would be Open Policy Agent if I wanted to write custom policies for my admission controller. Now, I paint kind of a broad picture for what's with serverless in Wasm. Serverless, I'm going to define it here as something that lets me write just my business logic. I send it to some managed service, and that managed service operationalizes my Wasm module. So Cloudflare and Fastly would be kind of more what you probably think with serverless. Spin is a new technology from a startup called Fermion, and Wasm Cloud is another example of new platforms that are cropping up that are targeting Wasm specifically. In the CNCF space, you can go to CNCF landscape. I know it's overwhelming and like just a ton of logos, but there is a section now that's dedicated to Wasm. And why would they do that? Well, I mean, obviously I gave the examples for Envoy and OPA, but there's also new tech coming up where I can run Wasm modules like I would run containers and run it side by side with Docker containers. That might sound crazy, like we've been spending, about 10 years now trying to figure out how to run containers well, how to secure them. And that, to me, is like, yeah, that's exactly why I would rather us run something like Wasm, because with Docker containers, they do provide better security, better operational runtime, but it comes with a lot of downsides. Not everything is secure by default. I've got to make sure that my container isn't running as root. I've got to scan my container to make sure that the operating system that it's pulled in has all the latest hotfixes and isn't pulling in something that's gonna cause me to have to reship all my software and get paged while I'm here at DevOpsConf. So that would be one example, and there are a couple runtimes now that use it. With crypto and Web3 and kind of some of those emerging markets, Wasm is often the backend for running smart contracts. And that makes a lot of sense because just like with serverless, running in somebody else's managed service, running with plugins, trying to sit on the side of like somebody else's, as a sidecar to somebody else's service. And then same thing with smart contracts. You might be running on somebody else's machine. You need to make sure that that's sandboxed. And so that's why Wasm is so compelling for that use case. And portability. So that really was my original use case of looking at Wasm back in 2015. And there's a really great blog post by Prime, well, not Prime, by Amazon about what Prime Video is doing. And they are basically refactoring a lot of their code base to Rust so that they have a lot of the safety guarantees that the language provides. And in many cases, they are converting individual units of logic to Wasm, and that gives you a lot of amazing things, like not having to compile for multiple architectures and having a single unit of output, and then it's isolated. And finally, I promised to talk about databases, so there's a data space. And SingleStore is not the only database that's interested in doing this. There's ScyllaDB, TIDB. If you're doing data streaming, Infineon is pretty cool to check out. And into the data space. I'm going to do the raise the hand thing, actually. So how many of you recognize a technology in this stack? Just raise your hands. Are you using something here? Yes. How many of you are using more than one of these things? Yeah, multiple people. Like I'm seeing like maybe 20. And that's totally normal, right? In the data space, you're writing an application. You might start with Postgres. Then you add something like, that needs to be for operational data, like customer orders. So you're going to throw in something like Snowflake. You want to use some third-party data source. So you're either looking at like, some type of object storage, or you're looking at MongoDB, some type of boutique database for handling JSON data really well. You're probably bringing in data from some type of stream, like with Kafka. And you know what? There's a ton of latency introduced because now we're replicating across all these things. And it's getting slow, so you slap in Redis in there, and boom. You've solved the problem, but you've solved it in a really, really complex way. That's difficult to scale, that requires multiple people to have operational knowledge to run this. And there's one little piece here where you're typically going to have some type of data lake, like maybe with Spark, and those quickly can become data swamps, because again, you're running all of those types of replications. You might not be able to get your answers immediately. Now, my company, Single Store, we're trying to solve this problem in a way that sort of unifies some of these in like a more general answer. But I'm actually on a team called the Launchpad team. It's sort of like an innovation team at Single Store. So like the engineering team in my book is solving this problem. And the problem that I'm interested in solving is like over here. So notice that there's only one arrow going out of Single Store now. And I want to figure out, what do we need to do to make that part not happen? And that is where Wasm enters the scene. If you're not a database person, which I realize nobody brought their DBA, so dang, user-defined functions are really common in SQL databases. It lets people write SQL code and then kind of like make it really easy to run in stored processes and other operations. If you have a Wasm UDF, I don't have to write SQL. I can write it in C, C++, Rust, Go, any language that compiles to Wasm. And the way that I send that up to the database is I run one SQL statement, and that's create my function with my function name as Wasm. And I pass in my URL to my Wasm function. Now, there's a lot of ways to solve this problem, to add extensibility to databases. We've been doing it for like over 20 years. A lot of people have done it and failed. But I believe that this solution is the only solution to make it work at scale and with the level of data intensity that we have today. And that is being able to run in the data process. So when I have a Wasm function that's running as a user-defined function, I am now able to run it as part of the query plan, in step with any other code that we've taken from SQL, compiled it to machine code, taken my Wasm module, compiled that to machine code. I know that the restrictions of the language, because it is designed to be sandboxed, safe, secure, and fast, I am able to run it in line with other code, which means I'm not copying the data around. The only way to do massive data at incredible speed is to not copy data around. And that's that whole point of showing that original picture of like, data's moving everywhere. It's really complicated. What if we just don't do that? And what would that future look like? The other cool thing that I threw this in here, actually like right before I stepped up here, is that you're able to use familiar IDEs and tools, AKA Nobody Puts Database in a Corner talk, where we talked about, hey, maybe it would be great if you started committing your SQL statements. Well, I would say, hey, use Rust or whatever language you're familiar with, use the libraries that you're used to, write unit tests, debug, and have the deployment all built in, like you would expect, and then that gets deployed to the database. And now you've got a lot of really great operations around the things that you're running in your database in a very modern way. Whenever I talk about Wasm, I always say any language that compiles to Wasm, and then people pick that up. They're like, oh, okay, so you're caveating that. There are languages that are interpreted. They're not strictly typed, and they're kind of hard to convert to Wasm. Python is one of them. We make a database. Data science is going to be our #1 customer. So #1 language in data science is Python. Now, there are other ways that other databases are embedding Python. And I've kind of talked about how, if it's not in process, I don't like it. But let's say that I wanted to solve this without Wasm. Well, what I would do is probably create some kind of VM or a Docker container. I'm running it out of process. I've sandboxed it using conventional methods. And now I'm communicating with the database by either like some kind of network call or inter-process communication. So data's moving, right? And so all of a sudden, I've had a major impact on my performance. And there are a lot of security questions here, too, that you have to answer to say that, I will take anybody else's code from the internet and run it on my managed service where I'm running, operations like Bank's code that I really can't afford to lose that data. But I was really excited to see this this month. At the end of the month, there's PyCon, and one of the keynotes is going to be discussing how Python 3.11 is going to have alpha support for Wasm. So it's been working on for a couple of months now, and I really hope that it's going to be available so I don't have to do all the other infrastructure complexities to make it work in my database. So I promise that I'm thinking about how to eliminate data swamps. And one of those ways is to think about how data scientists typically work. They usually are running in a notebook. They query some data source, and then they get the results back. Like, that's without Spark. Most people have some type of data lake in between that lets them scale horizontally. So say they're running Spark, and so they query Spark. Spark queries the data source. Spark takes that data out of the data source, does some type of transformation and computation, and then only returns those results back to the laptop. And this is incredible, right? I'm now able to work on a huge amount of data that I couldn't do before, that wouldn't be able to run on my laptop. But I want this. I want the only data movement to be coming from the database with the answer. So how do we do that? I'm going to run a live demo. If you want to pull up this demo, the sample code is here. I should say that our Wasm UDF support is going to ship in this summer. So this isn't available just yet. This is running from, my machine. So demo gods, away. Let's do sentiment analysis. If you're not familiar with sentiment analysis, that's basically being able to say, given this text that somebody sent me, were they positive, negative, or neutral? I'm going to connect to the database. Cool, that worked. Now, I'm going to show you a little bit about the data that I'm pulling in. That's 82 million rows. It's Stack Overflow data. And I am a little competitive. You probably don't know me, but if you did, you would know that while internet points don't mean anything, they mean something to me, and I want to find a way to game the system. We already know with questions and answers, you can kind of imagine exactly what makes a good question. It's not duplicated, they explain their problem well, and a good answer is, the answer. But did you know that in comments, you can also upvote and downvote those comments? So what do you think good comments are? What are the most highly voted for comments? Is it like Reddit, where they're just really funny? Is it, oh man, this is awesome, it totally solved my problem? Well, let's find out. So against this fairly large data set, I'm going to look at a little bit what this data looks like. So we get some text, hi Mark, I haven't tried that, kind of what you would expect in comments. Did it? Cool, okay. And there's a score. I peeked at the first 10, so the scores here are 0. So apparently, hi Mark, not very compelling. They were like, whoa, why do you know my name? Let's do some sentiment analysis. So this is an example of something I would never want to write myself in SQL. I'm not that great at it, but what I am really good at is finding open source tools and just wrapping them and then running them myself. And so that's what I did here. I took an open source crate, created some Wasm bindings. So really tiny wrapper. Actually, I'll show you what that looks like. So here's my librs. And it comes up with polarity scores, whether or not it's positive, negative, or neutral. And we just generate the Wasm interface, those extra bindings. Back to here. So if I create my function in the database, I'm saying, in this example, I'm grabbing from object storage and pulling in my Wasm module. And now that it's loaded, I can say, hey, DevOps Day is awesome. Well, the computer doesn't really know what DevOps is. We just said that maybe none of us know what DevOps is. So that's understandable, but I said it's awesome, so that means it's pretty positive. If I said something like, I don't know, read the docs, that's totally neutral. So that makes sense. My computer's not very good at figuring out when somebody's being passive aggressive. So we have to understand that part when we're looking at the data. I definitely have that type of bias built in. Now, what I want to do is look across this entire data set and create some bins. The interesting part that's running here is this join. So I created a sentiment function that returns a table, so a sentimentable, if you will. And that function created me some buckets. Those buckets are by 10. And so I'm looking at basically, okay, run this across all that text and tell me what the average is in each bucket. Now, I might work at a database company, but I still can't look at tables and get a lot out of it. I've got to plot it. So I'm going to run a simple plot here. Hopefully you can see that okay. Yeah. So this diagram's a little weird, so I'll explain it. Positive and negative are plotted on the y-axis. So 0 being very, very neutral, both for your positive and negative data points, and then 1 being either very positive or very negative. And then on the x-axis, those are my bins. And what we see is that over time, comments are trending neutral. So the highest rated comments were very neutral in response. So they maybe were, maybe the idiom that the answer is always in the comments is actually true. And so that's neat. But there's one more thing, and that's if you are positive, then you're more likely to still get upvotes than if you were negative. So if you take anything away from this, maybe be kind in your comments. So that was my demo. And you can look at the code for how I generated that Wasm function and then the notebook that I ran in. So what did I just do? Well, I ran a function across several different nodes. So it was distributed, so it has horizontal scaling. And I did something that most databases aren't able to do today, which was run AI and ML in the database against a very large set of data, which is pretty cool, in my opinion. But why would I show something that's very databasey at a DevOps conference? Well, if I'm able to do this in a database, what can you do in your stack? Probably anything. So consider it. And that's it. We're hiring. I'm based in the Raleigh office, and my team, if you thought what I showed was pretty cool, come work with me. That would be awesome. And yeah, so I think I probably have a few minutes for questions. Yeah, okay. Anybody want to ask me about Wasm? Oh, yeah. Okay, okay.
Your performance is very fast. Are you leveraging in-memory data for your analysis? Is that how you're achieving the performance? Because UDFs are classically underperforming.
Yeah, okay, so this was a great question. First of all, he left his DBA in a closet. That's unfortunate. But the question was about the performance there. And yes, that is one of the main reasons why people use our database. I'm not here to pitch about that, but I think the technology behind it is really interesting. You might have heard of us as MemSQL. About a year ago, we changed names. And at that time, that name made a lot of sense. We're a row-oriented database, but now we've since added a column store. So the column store engine is actually sitting on top of the row store. It's a log-free skip list. And the column store is leveraging the performance of the row store to do operations like that. And that compilation was cached. I had run that query like 5 times before I stood up on stage because I was really worried that it wouldn't work. But if I'd run it cold start, which we could probably do, I think it comes in around 6 seconds, which is like insanely slow for our database. So like I said, we haven't shipped this yet, and I haven't done any type of performance tuning for what I'm running right now, and that's kind of what I'll be doing for the next month. And so essentially it's running sort of interpreted, and what I really should be doing is what other browsers do, which is take that Wasm code and then compile it into machine code. And so I'm running it like interpreted, which is probably the worst thing ever. And this crate is not small, so yeah, there's a lot more I can do there. Any other questions? Okay. Well, I'll be hanging out for the rest of the day.
All right, so we give a hand.